This is a video on absolute value inequalities. Basically, to solve an absolute value inequality, we use two rules to help us out. The first rule here, if the absolute value of x is less than a, then we say negative a is less than x is less than a. So really, we can rewrite absolute value of x less than a as negative a is less than x is less than a, where a is just a number. And the second rule we have is the absolute value of x is greater than a, so it's different for greater, then x is greater than a or x is less than negative a. So we're going to rewrite it in this form. I'm going to show you why these rules are true, and then we'll actually go through and solve some inequalities with them. So for this first example, the absolute value of x is less than 2. Remember that absolute value of x really means the distance from 0. So we really want numbers whose distance from 0 is less than 2. So if you think about this in terms of a number line, right, and here's 0. If I want numbers whose distance from 0 is less than 2, here's 1, here's 2, here's negative 1, here's negative 2. What I'm really saying is I want numbers, if their distance is less than 2, between 0 and 2, and 0 and negative 2, because the distance from 0 there would be less than 2. So really I'm looking at, from over here at 2, and from negative 2, and everything in between. Because those numbers all have a distance from 0 that's less than 2. So if I think about how I could write this as just a regular inequality without the absolute value symbol, really I'm starting at negative 2. I'm not including it. Alright, and then I want everything in between, so all these numbers in between we'll call x, all the way up until we get to 2. Alright, so we have negative 2 is less than x is less than 2. And then we have that inequality rewritten. So the absolute value of x is less than 2 really means negative 2 is less than x is less than 2. Because the distance from 0 there is less than 2. It's just another way of rewriting it. So this was basically that rewrite step, and it shows that first rule A from the previous page. Alright, where if you're looking at the rule, let's go back to it real quick. If the absolute value of x is less than a, then we can write it as negative a is less than x is less than a. In this case, we used a as 2, because the absolute value of x was less than 2. So we rewrote this as negative 2 is less than x is less than 2. It's all based on that number line, though, and the distance from 0. It's a little different for greater than. If we look at the next example, we got the absolute value of x is greater than 3. For greater than 3, alright, if I want the absolute value of x to be greater than 3, think about this on a number line. We need the distance from 0 has to be more than 3. Remember, absolute value really means the distance from 0. So if the distance from 0 has to be more than 3, alright, and we'll go negative 1, negative 2, negative 3, negative 4. On our number line, we want the absolute value of x to be greater than 3, meaning the distance from 0 to be greater than 3. We really want everything to the right of 3 here, right? Numbers that are a greater distance from 0 than 3 would be further out this way. So I'm really looking at from 3 and everything over in this direction. And if I go out to negative 3, if I want the distance from 0 to be more than 3, because the absolute value means I really want to start at negative 3 and I want to go out in that direction, right? Because I want to be further away than 3. The distance has to be more than 3. So if I wanted to write this as an inequality, really what happens is this piece here on the left really tells us that x is less than negative 3. Right? Because those numbers are smaller than negative 3, so it really tells us all these values here, x, are less than negative 3. Or, over here you've got the distance is greater than 3 from 0. This would be x is greater than 3, right? All these values are bigger than 3. So if we rewrite that as x is less than negative 3 or x is greater than 3, that really gives us that second rule we were talking about. So this is really the rewrite step down here. If you have an absolute value inequality with a greater than, you want to write it as two separate statements. You can keep it as x is greater than 3, just dropping the bars. That's what this piece gave us over on the right. And then you can say x is less than the negative of the number here, because you want to take care of that piece as well. So that gives us our second rule. It's easiest probably to write this in the order of write exactly what you see. So if I'm rewriting this up here, I'll write exactly what I see without the bars, and then write or, and then you want to start with x still, and then you want to flip the sign here to be a less than, and then make that a negative 3. These mean the same thing. It's just a nicer way to rewrite it. Let's take a look at a couple examples with actual absolute value inequalities that we have to solve. So this says solve the absolute value inequalities below, graph your solution on a number line, and state your answer in interval notation. The first thing that's important to notice here is that the absolute value of 4x minus 1 plus 6 is less than 11. Whenever you're solving an absolute value inequality, you want to get this absolute value bars by itself or alone on the left-hand side. This way we can use one of our rules. So my first step here is I'm going to subtract 6 from each side, and this actually ends up becoming the absolute value of 4x minus 1 is less than 11 minus 6, which is 5. Now that I have this absolute value inequality here, now it's time to rewrite. Right? So this is always a rewrite step. RW here stands for rewrite. And the way you want to rewrite it is, you got this absolute value of 4x minus 1 is less than. It's all based on this sign that we have, or this inequality symbol. The inequality symbol here we have is less than. When we have less than, all right, that's the one where we write it in between. All right, so if the distance from 0 is less than 5, then you want to be between negative 5 and 5. So the way we rewrite this is negative 5 is less than, and then you can drop the absolute value bars. We just write whatever was inside of them, 4x minus 1. All right, and then is less than, and now we write positive 5. And now we want to solve this inequality. All right, the way we solve this inequality is you really want to isolate x in the middle. So I have to isolate it just like if I would solve an equation. All right, so I'm going to add 1 to each side. So I'm going to add 1 here, add 1 here, and add 1 here. Make sure you do it to both sides of this inequality. Negative 5 plus 1 is a negative 4. Is less than, this is 4x, which is less than 5 plus 1, which is 6. All right, and then to solve for x, get an x by itself in the middle. You want to divide by 4, divide by 4, divide by 4. This will give us negative 1. Negative 4 divided by 4 is a negative 1. Is less than, the 4's cancel here, so we're just left with x is less than, we can reduce 6 over 4, which reduces to 3 halves. Alright, so we've solved the inequality. That's how you actually would solve it. You get x by itself in the middle there, and we have the inequality. Negative 1 is less than x is less than 3 halves. This also tells us to graph our solution on a number line and state our answer in interval notation. So I'll do that in the next page. So we have negative 1 is less than x is less than 3 halves. And on the number line, alright, so on the number line, it really looks like this here. I would just put down the numbers you have. You don't have to put 0 down every time. Negative 1 is my limit on the left-hand side. The right-hand side goes up to 3 halves. And then this x being in between here tells you want everything in between. So when you see a less than, alright, and there's no equal to on it, you want to use an open circle on that number. So negative 1 is less than x. We want an open circle there. Alright, and on 3 halves, this is less than, there's no equal to on it, so it's an open circle as well. And this x being in between them tells us we want to shade everything in between. So we're really shading in between there, and that's what our number line would look like. Sometimes people learn to shade it on the actual number line. I'm just doing it above so you can see the difference of where I'm shading. So that's our number line, and then in interval notation, what we really want to see here is, alright, we start at negative 1. There's an open circle there. We're not including negative 1 in our solution. So there's an open circle. So we use a parenthesis, negative 1, comma, and this goes all the way up till 3 halves. And then close parentheses because we're not including 3 halves. The open circle means we don't include it. So this would be our complete answer. We solved the inequality. Negative 1 is less than x is less than 3 halves. Alright, we have it written on a number line, and we have the interval notation. Let's take a look at an example now using absolute value inequalities with greater than. So we're going to solve the absolute value inequality below, graph your solution on a number line, and state your answer in interval notation. So same instructions we had in the last one. And on this one here, what you really want to do is the same thing we did before. You want to isolate the absolute value on the left side of the inequality. So to start, I'm going to add 4 to both sides. And add 4 here. If the absolute value was already isolated, you wouldn't have to do this step. Alright, so we're going to end up with the absolute value of 3x plus 5. Alright, is now, these 4's cancel, is greater than or equal to 7 plus 4, which is 11. Now this is a greater than inequality. Alright, the equal sign in there means use greater than or equal to, but you're still following the rules for greater than. which is, first we have to rewrite. And when I go to rewrite this, for greater than, I like to remember it as, write exactly what you see, just without the bars first. Alright, so it's 3x plus 5 is greater than or equal to 11. And remember, greater than is an or statement, so it's greater than. So, or, these numbers have to be, the 3x plus 5 stays the same. And then you switch this to less than or equal to negative 11. Remember, this all has to do with the distance from 0. Right, if I want the distance from 0, the absolute value to be greater than or equal to 11, that means that I need this piece here to be either more than 11 on the number line, or it has to be less than negative 11, because it has to be farther away than 11 units from 0. That's where these come from. Alright, it's probably easiest to remember the rule, but you should have an understanding where it comes from. And now we want to solve each of these individually. So I'll solve this left inequality first. So I'll subtract 5 from each side here. And I've got 3x is greater than or equal to 11 minus 5, which is 6. And then to solve this, divide by 3, divide by 3. So I have x is greater than or equal to 2. Alright, or here, solving again, it's going to be the same process, but you have a different number here, so it's going to change a little bit. So subtract 5 from each side, you're going to have 3x is less than or equal to negative 11 minus 5, which gives us a negative 16. And then we divide by 3, so we got x is less than or equal to negative 16 over 3. Now realize that when we're looking at this, you know, if you have a fraction, keep it a fraction. It's still a number like anything else, right? Don't give me a decimal number here. We want to see this as a fraction. Alright, so we have our solution. Now we're ready to graph it on a number line. We're going to graph both these inequalities on the same number line. So I'm going to go to the next page and we'll do that. So we had x is greater than or equal to 2, or x is less than or equal to a negative 16 thirds. And when you're drawing your number line, make sure you put these in the correct places. Alright, negative 16 thirds and 2, those are the numbers we need to use. Make sure you put them in the right order. Negative 16 thirds is definitely less than 2 because it's a negative number, 2 is a positive number. And if I'm looking at this, to graph the number line that goes with x is greater than or equal to 2. The greater than or equal to, the equal to part tells you that you're going to have a closed circle, alright, on 2, coming from this inequality over here. And x being greater than or equal to 2, greater than means that you want to go to the right. Remember, greater number is always to the right. And the x is less than or equal to a negative 16 over 3. Alright, the less than or equal to, the equal to tells us, alright, we can fill in the circle there. Alright, we're including negative 16 over 3 in our solution. And we want to shade this, since we want x is less than or equal to that, less than means we want smaller numbers are to the left hand number line. So this would be the number line that goes along with this solution up here. Lastly, we want interval notation. For the interval notation, we want to start from left to right. So you're always looking at from left to right. I always use my number line to help me. From the left, this number line goes all the way out to negative infinity. So you want to start with a parenthesis and then negative infinity. You always use a parenthesis when you're using it for an infinity or a negative infinity. So we want parenthesis and negative infinity because this goes all the way out to the left to negative infinity. And it goes all the way to the right until you hit to negative 16 thirds. So I want to go to negative 16 thirds. And then you want to use a bracket here. And use a bracket because you're including the negative 16 thirds. In other words, that circle's filled in, or it has an equal to, however you want to think about it. But that bracket signifies that we're including negative 16 thirds in our answer. And then we write union here. This union symbol is just a U. Alright, it means or. Alright, just like we were doing before. And then we start back up with the rest of our number line here. Well, I start at 2. I'm including 2 because it's a filled in circle. Alright, so you want a bracket 2, comma, and then this goes all the way out to infinity because it goes on forever out there. And infinity gets a parenthesis on the end. So this would be the interval notation that goes along with it. Alright, so here's our interval notation. And this is our number line. And this is actually the solution. Alright, so I hope this video was helpful. Here's a couple for you to try on your own.